And then for the third one, I'm going to draw one that goes through the center. The angle should be approximately the same. There. So here's my object again. Object now is what? Real or virtual?
Real.
It's still real. Inverted? Yes. It's inverted, right? It's upside down. S prime is positive? Yes. Smaller or larger? In this case, it's just larger. It's larger. And we'll see with the formula, if you put the object exactly at the center, you will get it to be the same size as the image. Okay. And finally, for this one, here is the focal point, and here is C. And let's say our object now is this way, is here, with the focal point and there. Let's draw the first ray. Parallel. It will do what? Go through the focal point. This way, it will reflect that way, right? Yeah. The one through the focal point, if I draw one through the focal point, it's just not going to come back. Okay, so I drew just this. What's happening to these? Are they meeting? No, they're not going to meet. So what happens is, they're extensions with it. The extension of this one, this way, the extension of this one, be this way, and you would see what kind of image? It would be upright. Is it? Because the arrow is the same direction. It's upright. So let's look, real or virtual? In this case, it's virtual, so it's not real. Upright or inverted? It is upright. The arrow is not like upside down. S prime is negative. Smaller or larger? Larger. So basically, everything, it's just the opposite of this. Yeah.
So because they don't intersect, we see them in the mirror?
Yeah, there, it's behind the mirror. Yeah. It is behind the mirror. Yeah.
All we did was use two arrows though to find a point. Is that enough?
Yes. Well, we draw the arrows that we're sure about the angles, that we know them. So I can draw another arrow maybe here, but then how does it reflect? You have to draw, you have to find angles and stuff like that. So it's not that easy. So for this one, for example, I know it's going to make this angle, so it's going to reflect somehow this way. And so it's extension. Obviously, I'm not drawing it the best way.
But once we have the actual point of where they're gonna meet, we can actually find the reflection of everything. Cause we can just use that to.
Yeah, just two arrows are enough, two rays are enough, yeah, where they intersect, yeah. Yeah. And so for this concave mirror, you can see, if you're, I don't know what the radius of curvature is, but it seems big. You can come closer and you will not see yourself until you get really close. That's when you see your face. And that's a virtual image. Okay, you see. Can you see my hand there? Not really, right? Not very much. But if I get close, that's my hand. Is it real or virtual? The image. It's virtual, it's behind the mirror, and it's bigger. It's bigger. Yeah. So I can estimate, I don't know what the curvature of this, but it seems like the radius of curvature is like maybe somewhere here, and the focal point is here. So when I put my hand here, it's somewhere between the focal point and the.
Wait, so how does real look?
We will see real images in the lab through lenses. For this one, think about it this way. If you have a real image, let's say the sunlight, this one will be able to focus sunlight somewhere here. Right? If you have, let's say sunlight comes from very far away, there are parallel rays.
Oh.
and they will all come to the focal point. If you put a piece of paper there, you can burn it, because you get all the rays in there. Yeah. All right, so that is that. Let's see. I had something else in mind. Let's see. Yeah, we didn't quite get to the derivation of the equation, but I will get to it. Probably next. Yeah, go ahead. You had a question?
No, just a comment. If in this mirror that's like completely concave, the whole image is inverted, right? So if you found one that was like straight in one side but just curved on one, would it have like just flipped horizontally, like just vertically
So
flipped?
like a combination of mirrors?
Yeah,
One is,
almost like straight but like
Yeah.
just indented. Like it
you
was
will
like-
have different, two different images. One of them is from the flat mirror, and the other one is from the spherical mirror.
If it was like a cylinder, is what I'm saying, like the inside of a cylinder.
Now, I don't know. Depends on the geometry, how it's going to, how it's going to reflect. I don't know. That's the short answer.
What about like the silly mirrors and like at circuses or wherever they are?
I'm not familiar with them, but
They're like
are they?
squiggly mirrors.
Oh, okay. Yeah, I mean, yeah, you can get all kinds of, it's just based on the reflection. Yeah, it's just, I remember something. For the convex mirror, for the convex one, just before we leave, for the convex one, this is F and this is C, and your object will stand here, right? Will stand here. In that case, you will send the ray parallel, but how is it going to reflect? So this is the center, right? So that's the perpendicular, so it will reflect at some angle this way, right? So what happens is when it reflects, this one, its extension will pass through the focal point. So that's the outgoing ray. But then, how about this one? Let's draw another one. This one here, it will reflect some angle like so, right? But the outgoing rays will never meet. It always diverges them. But the extension of this one and the extension of this one meet here. So you get a virtual image that's smaller. So your image will always be smaller, this one. It's always small for a convex mirror.
Show the camera, show the camera.
So, yeah, let me stop for this one here. Next time, we will do the math, more math.